Up to here completed, right? Guys, the system has two nodes and they are mass m1 and m2. And we'll write the force balancing equations here. We're going to write force balance equations. So those, let's move to next slide. Write down the displacement of mass m1 be x1. If you see there, see here, no? What is the displacement of this m1? It is x1. Similarly for m2, it is displacement is x. Kindly observe this. This is the important thing now. But observe this clearly. Oh my god. Okay. So for m1 it is displacement is x1 and for m2 it is x. Okay. So let's run that way more. Not on m1 be x1 and the opposing forces acting on mass m1 are. What are the opposing forces are there? What are those? All those things. So its displacement is first one is x1. Next its itself force, that is mass itself, that is fm1 towards mass, and another force is fb1 and one more fk1 and one more thing fb dash part. This is in between. This b1 is only for m1. This fb1 is only for m1 only, and next one is fk. So anyone respond for this? What is the equation for mass Fm? See the back, check it. Last class slides చూడండి, previous class. Mass equation ఏంటి, dash part ఏంటి, spring ఏంటి, directly proportional with respect to second derivative, first derivative, or else constant, like that. Yes, respond at least one.
M into second derivative.
M into second derivative. That is m suffix 1 here. That means mass 1. So we'll write it as m1. And its second derivative means d square x by dt square. It is x or x1 displacement here. x1. That is mandatory. Please check it. Okay. Next. For what about b? That part it is single derivative. b1 into dx1 by dt. And for spring, that is k, it is simply constant k1 x1. Next, similarly b, it lies between two displacements or single displacement. That's part b. Is it ideal or in between two masses?
In between.
In between. In between means what about displacement? We are treating m1 as reference, means starting. So how to write displacement here?
M1 minus M2.
M1 minus M2. In terms of displacement, we have to write now. So d into d by dt of, very good, x1 minus x. Similarly, what about fk? K into
x1 minus x.
Yes, that's enough. Thank you. So write down by seconds law. So by Newton's second law, all the forces are equal to 0. Are equal. That means sum of incoming equals to outgoing, like that. Okay, that is fm1 plus fb1 plus fk1 plus fb plus fk equals to 0. So all those right here. That is all those right here, no? Then you will get m1 into d square x1 by dt square plus what is the next term? b1 ki b1 into dx1 by dt. Next fk1 వచ్చేసరికి k1 x1 Next, fb dash part b into d by dt of x1 minus x. Next plus fk is k into x1 minus x equals to 0. Guys, are you there? No issues? Internet? Yes, okay, done. So now apply Laplace transform. So if you apply Laplace transform to this one, what you will get? What is the single derivative? So if you, okay, no problem. Please write on this. D by dt means yes. D square by dt square means this is square and so on like this. Okay. So similarly, what about here? M1 into S as a square of
S square.
S square into here displacement is x1, so it is x1 of S. That is in S domain. That means you are converting into Laplace transform. So next V1 into d by dt single s
X.
into x1 of S plus k1 into x1 of S plus b into s into x1 of S minus x of S plus k into x1 of S minus x of S equals to 0. Is this clear all of you? Okay, now split those terms. X1 of S, x of S separate and then you will be like this. So after that, take x1 of S and right side to this side. This to right side, minus is there. Okay. After that, find out x1 of S equals to x of S into this value by total. Is this clearly visible, this color?
Yes, sir.
Or else shall I change any other? Is it okay? So this is x1 of S and assume this is as 1. Similarly, we will do for mass 2 also. Right? What are the forces acting on that mass 2? And you can write. The same thing you have to follow here also. Just take those relations and just apply Laplace transform. That's it. Completed? Yes.
Yes, sir.
Next, similarly write for M2 also. M2, that is mass 2. So here also the displacement here is x1, sorry, x it is. And here one force is outward, that is f of t is there. See the symbol there, direction of that one. And Fm2 and Fb2, next Fb, dash part, common to N1 and N2, and final, last but not least, K, spring. So here also note on all these things. So Fm2 means M2 into d square x by dt square. Here it is x ma, displacement is x. That's why we are taking x. In the previous one it is x1. Okay, similarly it is d2 into dx by dt. And it is d into the difference between, what is the difference here?
X minus X1.
Yes, very good. X minus x1. So here also k into x minus x1. So same by second law, apply all this. Undo this. FB means b into d by dt of. So now apply Laplace transform here also. And you will get m to s square into x of s. Isn't it? Plus p2 into s into x of s. Plus p into s into x of s minus x1 of s. Plus k into x of s minus x1 of s, which is equals to f of s. So here also separate the terms of x of s and x1 of s, no? And which are equals to f of s. Clearly note down. So assume this is equation 2. And better put equation 1 in equation 2. Then we get, see there, you can treat that x1 of s equals to some value is there. So directly you can put all the value here. x1 of s in the previous one. ఇక్కడ x1 of n చూసారా, ఈ x1 of s ని ఇక్కడ సబ్స్టిట్యూట్ చేశాను ఈ ప్లేస్ లో. Because you need in terms of output and input. Output is x of s and input is f of s. That's why. Okay. So what implies x of s into. If anyone can respond, please, after completion of about him. X of s into m2s square plus b2 plus b into s plus k. That's enough up to here, and minus x of s into, see the previous one, bs plus k by one more bs plus k is here, right? m1 s square plus a1 plus b into s plus a1 plus k into ps plus k equals to f of x. So cross multiply here, that means take LCM and then you and take common x of s in this 2 and take LCM also. So directly take x of s by f of s. That is the transfer function final. Okay. Completed to here.
Yes, sir.
Answer under. How many are there? 22 to 3. So that's fine. So let me expand this. So next click common in x of s. So common and then take directly LCM here. I'm taking x of s common now. And what is the denominator LCM? m1 x square plus respond that one.
B1 plus B into S
Okay.
plus K1 plus K
So this term is multiplied by this left. That means first term. That is m2 s square into m2 s square.
plus B2 plus B into S
Okay.
plus K
Plus k is multiplied by this denominator term, right? అంతే కదా. So these two are multiplied and whole minus so base plus k whole square, isn't it? Which is equals to f of s. Now the transfer function. What is transfer function? Output by input, which is equals to take this f of s this side and reverse this equation. You reverse that one. What is the final value? Just replica of the above equation. So this is the final transfer function. If you want, you can expand this terms now. Doesn't matter. If you need, if you want to extend this, you can. What is the final transfer function? This is all about mechanical translational system. Okay. Completed on. So we'll move to the next topic. That is rotational. Previous one is translational. Here it is rotational. Both are same, but notation will be different. That's it. Both procedures are same. Everything will be right. Everything is same, right? So this model of rotation on the quantum systems can be obtained by using three elements here. Moment of inertia of mass. Moment of inertia, that is J. Dash part with rotational frictional coefficient B. And torsional spring with stiffness K. Torsional spring with stiffness K. And here are the symbols we are going to use here. There is a force and here is the torque. There is force and here is torque. Write down all these things and tell me after. అందులో అక్కడ సిటీ అప్లోడ్ చేయని వాళ్ళు ఉన్నా సరే అవి కూడా అప్లోడ్ చేయండి. సిటీ ఎవరన్నా పెండింగ్ ఉన్న వాళ్ళు. Completed.
Yes, sir.
Next, write down torque balance equations here. So the same thing like previous one, just we replace x there. X is the displacement there, and here is the theta. Just changing the notations only. If F is there, T is here, like that. All those things. Write down as much as possible. Write down first. Completed.
1 minute.
Next here for the torque. Similarly, if the displacement is in, I mean, if the dash path has both ends are displacement and one end is fixed, two types are here, right? అది పోయింది జాగ్రత్త ఒకటి తీగ ఊడింది నాకు పర్లేదు బాగానే ఉండదు సిస్టమ్ The second one is difference mark. That is the dark spot is placed in between two displacements. That is theta one and theta two. That is why the torque is from left side. That is why theta one, right? Theta one minus theta two is here. So suppose if the torque is from this side, so you can write it as theta two minus theta one. If it is from this side, you can write theta two minus theta one. Okay, remember. Yes, completed.
Yes, sir.
Next, write on this third one, last one. Right up to here and then we will stop. Tomorrow we'll see the problem. One problem is there. And then we'll finish this first unit and all 4 units are completed till now. We will stop the fifth unit. I'm repeating again. Please go through the first 4 units as much as possible. As fast as possible, complete the syllabus. At least 2 units before the exam. 2 units perfectly, 100%. Then you can pass. If not, it's up to you. How many people are here? 22. Completed, ma? Guys, completed, huh?
Yes, sir.
Yes. Okay, let me stop here and then we'll see in the next class. No problem. Let me take the attendance again. 67,
Yes, sir.
67, 8, 76, 79,
Yes, sir.
80, 80, 84, 88,
Yes, sir.
95, 96, 98,
100 sir.
99, A0, 3, 6, 7,
Present, sir.
B0,
Present.
D6,
Present, sir.
C0,
Present, sir.
86 is C0.